Hi guys, hope you're doing great. Today we're going to have our new lesson using a Pythagorean identity, lesson 18.5, and this video is part 1 prepared by me, Ms. Salma Ahmed. Let's have a quick tour for what we are going to have in these slides. We're going to talk about the sign of the trigonometric functions in different quadrants. Explain 1. Finding the value of the other trigonometric functions given the value of sine theta or cosine theta. Explain 2, finding the value of the other trigonometric functions given the value of tan theta. Let's start the first idea, the signs of the trigonometric functions in different quadrants. Here we have number lines, 2 number lines. One is horizontal, which is the x-axis, and one is vertical, which is the y-axis. So if I'm going to start from the positive side of the x-axis, it's 0 degree. If I move to the one perpendicular to it, which is the positive side of the y-axis, it's 90. Any angle lies between 0 and 90, it will be lying in quadrant 1. Then I'm going to move from the positive side of the y-axis to the negative side of the x-axis, so it will be 180. Any angle between 90 and 180, it will lies in quadrant 2. Then I'm going to move from the negative side of the x-axis to the negative side of the y-axis, which is 270. So any angle between 180 and 270, it lies in quadrant 3. Then I'm going to complete my circle to go back beside the 0 to be 360. So any angle between 270 and 360, it lies in quadrant 4. So if I'm going to mention it as a radian, the 0 will stay as it is 0, the 90 it's pi over 2, 180 is pi, 270 it will be 3 over 2 pi, and going back to 360 it will be 2 pi. So if I have theta in the first quadrant, I'm going to complete this line. I'm going to complete it as a triangle, right triangle. So theta in quadrant 1, the adjacent is in the positive side of the x-axis, and the opposite is parallel to the positive side of the y-axis. So adjacent to opposite positive, and the hypotenuse always opposite. So the sign are positive all. I'm going to find the sign ratio or the trigonometric ratios, sine, cosine, and tan. So sine, it will be positive, of course, because opposite over hypotenuse, so positive over positive give me positive. Then cosine, it will be adjacent over hypotenuse, so positive over positive give me positive. And tan, it will be opposite over adjacent, positive over positive give me positive. So I found that all the trigonometric ratios in quadrant 1, they all are having positive sign. If I have theta between 90 and 180, so I found that adjacent is in the negative side of the x-axis, the opposite side is parallel to the positive side of the y, so it's positive, and the hypotenuse is always positive. So this will be opposite positive, adjacent will be negative, hypotenuse will be positive. Let's get the sine theta. So it is opposite over hypotenuse, so positive over positive give me positive. Cosine theta, adjacent over hypotenuse, so negative over positive give me negative. And tan, it's opposite over adjacent, so positive over negative give me negative. So here in this quadrant, I found only the sign having the positive sign, and the rest are negative. So I'm going to move, if I have theta in the third quadrant, which is the adjacent is negative and the hypotenuse is down, which is, the opposite is down, which is negative, and the hypotenuse is positive also. So the opposite is negative, the adjacent is negative, the hypotenuse is always positive. I'm going to get sine. So sine is opposite over hypotenuse, so negative over positive give me negative. Cosine, it's adjacent over hypotenuse, so negative over positive give me negative. And tan, it will be opposite over adjacent, so negative over negative give me positive. So I found in this quadrant that only the tan that have the positive side. If I have theta in the fourth quadrant, so I have that the adjacent is the positive side of the x, so it's positive. Opposite will be down, so it's negative, and hypotenuse is always positive. So this is positive, and this is negative, and this is a hypotenuse is positive. Find the sign. So it will be opposite over hypotenuse. So negative over positive give me negative. Cosine, it will be adjacent over hypotenuse, which is positive over positive, give me positive. And tan, it's opposite over adjacent, so negative over positive, give me negative. So I found in quadrant 4 that only cosine that have the positive sign. So here we have the trigonometric functions and the sign in each quadrant. Now I'm going to draw C in the middle of the coordinate plane. It's Cartesian, and we are going to follow from the dot, following the arrow, passing from quadrant 1 to quadrant 4. So I'm going to take the initial letters from each word. It will be A, S, T, C. So we found that this is Aztec trigonometry rule. We are going to, it will be a very helpful one in the following examples. Explain 1. Finding the value of the other trigonometric functions given the value of sine theta or cosine theta. The Pythagorean identity is sine squared theta plus cosine squared theta equals 1. You can rewrite the identity to express one trigonometric function in terms of the other. As shown, each alternate version of the identity involves both positive and negative square roots. You can determine which sign to use based on knowing the quadrant in which the terminal side of theta lies. Let's start if I need to find sine theta. So sine squared theta plus cosine squared theta equals 1. I'm going to isolate the sine squared theta and get the cosine squared theta on the other side by negative sign. Take a square root for both. It will be sine theta equal positive or negative root 1 minus cosine squared theta. So here I can get the sine theta. I'm going to repeat if I need to get cosine theta. So I'm going to use the same rule and isolate the cosine squared theta in one side. It will be 1 minus sine squared theta. I'm taking square root for both. So it will be cosine theta equal positive or negative root 1 minus sine squared theta. Here an example. Find the approximate value of each trigonometric function given that sine theta equals 0.766, where 0 less than theta less than pi over 2, find cosine. So let's remember that we took the rule from a while. Remember, sine square theta plus cosine square theta equals 1. So I'm going to deduce that cosine theta equals positive or negative root 1 minus sine square theta. This one that I'm gonna use, and I'm going to substitute sine square theta by this number squared. So it will be like this, positive or negative root 1 minus 0.766 all squared. By using your calculator, it will be cosine equal positive or negative 0.643. Now I need to know whether it's positive or negative, so I'm going to back to my quadrant. Let's remember the chart. So it's talking about 0 between 0 and pi over 2, so 0 and pi over 2, so it's quadrant 1. All the sign or the trigonometric ratios are positive. So it will be in quadrant 1, which is in cosine greater than 0 or positive. So I'm going to take the positive answer, which is cosine approximately 0.643. Let's have another one. Given cosine theta equal negative 0.906, where it's between pi and 3 pi over 2. The theta is between pi and 3 pi over 2. Find sine. Let's remember that we took it from a while, this rule to get the sine. I'm going to use the other rule, which is sine theta equal positive or negative root 1 minus cosine square theta. So I'm going to use it and replace it. The cosine square theta, I'm going to take negative 0.906 here in the square to be squared. So it will be positive or negative root 1 minus, between brackets, negative 0.906 all squared. So sine theta, it gives me positive or negative 0.423 approximately to the nearest thousand. Now I need to know whether it's positive or negative. So I'm going to back to my quadrant. Let's remember the chart again. So pi and 3 pi over 2, it will be in quadrant 3. So theta is in quadrant 3. So I'm going to check the sign in quadrant 3. It is negative. So I'm going to take the negative answer from this sign. So it will be sine theta is approximately negative 0.423. Let's have more examples. Given that sine theta equals negative 0.644, where it is between pi and 3 pi over 2, find the cosine. So here we are. I need to get the cosine, so I'm going to get cosine theta equal positive or negative 1 under the root 1 minus sine squared theta. So I'm going to replace sine theta by negative 0.644 all squared. Use your calculator. Cosine theta, it gives me approximately positive or negative 0.765. I need to know whether it's positive or negative, so I'm going to back to my chart. It will be between the theta between pi and 3 pi over 2. So pi and 3 pi, we are talking about quadrant 3. So theta is in quadrant 3. And I'm gonna check the cosine, it's negative. So it's less than 0. So I'm gonna take the negative sign to be cosine theta, approximately negative 0.765. Another one, cosine theta equal negative 0.994, where pi over 2 less than theta less than pi. So it's lying in this quadrant. Find sine and then find tan. So if I'm going to find sine, I'm gonna use this rule, sine equal positive or negative root 1 minus cosine all squared theta, cosine squared theta, sorry. So it will be positive or negative root 1 minus, I'm gonna take negative 0.994 to be squared. Use your calculator, it will be approximately positive or negative 0.109 to the nearest thousand. Now I need to know whether it's positive or negative, so I'm gonna back to my chart again. I found it's between pi over 2 and pi. So pi over 2 and pi, the sign here is positive. So I'm gonna take my answer, which is quadrant 2, and the sign is greater than 0. So I'm gonna take the positive answer, sine theta is approximately 0.109. If I need to get tan, as we know, it's sine over cosine. So I'm going to substitute the sine that we get it from a y and the cosine that give it to me up. By using your calculator, you will find it's tan, which is negative 0.110. As I'm gonna check that in this quadrant, which is quadrant 2, really the tan is a negative sign. I'll have the negative sign. For more practice, you can answer page 986, number from 1 to 4, and page 987 from number 5 till 8. Thanks for watching and have a nice day. Please watch the next video because it's part 2. Thanks very much. And if you have any question, just contact me.